Howdy folks, welcome back to another Out of Spec Renew video. Today we've got a 2020 Hyundai Kona here, and it's got some pretty major powertrain issues that we're going to go ahead and fix today. Alright, so I'll go ahead and show you guys what we've actually got going on here. So, like I mentioned, this is a 2020 Hyundai Kona, and we've got 149,000 miles on it. And as you can see, if we go ahead and start it up here, it starts up normally. We don't have any error messages or anything like that. The real magic happens when we go to try and put it into gear. So if we put it into drive, I take my foot off the brake, you can hear those grinding noises. It actually just shifted back into park, but you could hear it was actually still grinding after it went into park. We'll try it again here. It's definitely unhappy. So we'll go ahead and shut that back off now. Now these, both the Kona and the Nero, which of course are kind of sister cars to each other, are pretty well known for having gearbox and motor noise issues. The owner of this car actually tried to get this covered under warranty previously, and they wouldn't cover it under warranty. I guess it's some kind of weird situation where she kind of bought the car new, but technically it was secondhand because the dealer had bought the car initially and taken advantage of the tax credits and then resold it or something along those lines. So it didn't actually have the 100,000 mile powertrain warranty the way I understand it. Instead it had the secondary owner 5-year 60,000 mile powertrain warranty. At least that's how I understand the situation here. So anyway, Hyundai wouldn't cover the noise issues for the gearbox under warranty. So she just continued to drive it, and then now we're in this situation where we've got a catastrophic failure. So initially I thought that maybe it was going to be an issue with the motor spline, with the splines where the motor and the gearbox interface with each other. But I found out that actually the failure is within just the gearbox itself. And we'll go ahead and get the car up in the air here, and I'll show you guys what exactly I found that leads me to believe that that's the case. So I've got the car up in the air here, and I've pulled the aero shield off here, as you can see. Here we've got it on the ground. You can see this thing is absolutely drenched in oil. So that's sign number one. We can also see we've got oil all over under here. And I could see it dripping off the AC compressor right there. You can actually kind of see some metallic particulate in the oil there. If I can get the camera to focus. Right at the bottom of that droplet, that silver, that's actually metal in the oil. And if we look back here behind the compressor, you can see there's a big crack in the gearbox case. My light's kind of in the way. Let's see. There you go. So that right there is a crack in the gearbox case. So we've definitely had some sort of catastrophic failure within the gearbox. The other thing that makes me realize that it's not a spline issue and instead is just a gearbox failure is that I can actually spin both wheels even with the car in park. So the parking pawl is clearly not engaging, and that would be located on the primary drive gear within the gearbox. So clearly we've got some kind of failure either between the differential and the primary drive gear. So, you know, could be stripped out teeth on the counter gear, or, you know, whatever kind of mechanical failure is going on there. But clearly we've got a mechanical failure that's causing the differential or the wheels not to be mating with the motor. So mechanical failure mode here. And yeah, so what we're going to go ahead and do is we're going to actually pull the motor and the gearbox out of this thing. I have got a brand new gearbox straight from Hyundai to put in this. We're probably also going to likely replace the bearings in the motor because those are kind of a known problem area for making noise. We'll check it out and see if it actually needs it or not. If it doesn't need it, then maybe we can forgo that. But I did quote the customer to do that work, and most likely, especially at the mileage that this car has, it's probably something that we want to have done. So yeah, without any further ado, I guess let's go ahead and get into this thing and start getting ready to drop the motor out. All right, first step, as per usual, on anything like this is we've got to disconnect the high voltage system. So I've already gone ahead and disconnected the 12 volt battery. The high voltage disconnect lives under the back seat here. So just pull the cushion up, and then there's a cover right in the middle here that's basically just kind of glued into position. All right, I don't think we've got any fasteners, yeah. So I should be able to just kind of pry that up and get it out of the way. So let me grab some tools for that. All right, so I've already kind of pried this cover off. Just gotten it sort of peeled out of the way, but that's just glued down with some butyl to the floor. And then this right here is our high voltage disconnect. So we're gonna pull this yellow tab back, and then we can just lift the locking handle and pull the disconnect right out of there. Simple as that. So now we can start doing disassembly on the top side here. We are going to have to remove the traction inverter and some of the other hardware here on top. And I don't know if you can hear it, but I've got the coolant draining down below. There's actually just a petcock on the bottom side of the radiator over here on the passenger side that you can remove, and it'll just drain all the coolant out of the system. This cover right here just pops right off. And then we've got our traction inverter here. Well, no, I take that back. This is actually the onboard charger, and then the traction inverter is below this. So the traction inverter is down below. That actually contains the DC to DC converter as well. But this right here is just the onboard charger. This box right here is kind of the high voltage junction box for the CCS DC charging. So you can see our two big cables coming from the bottom pins on the charge port. They go into this box. There's some contactors in there, and then that goes back down to the battery. This also acts as the junction box for the rest of the high voltage distribution. So the cables that come up from the battery go to this box. There's a couple of bus bars that pass through right here that connect to our onboard charger. And then there's also more bus bars down below that pass into the traction inverter. Anyways, so we've got to start pulling this stuff apart. It's been a little while since I've done one of these, but if I remember right, I think the first thing we want to do is unplug everything from our junction box here, and we want to disconnect our two bus bars from it, remove the junction box assembly, and then we can start taking apart the rest of the stuff above it here. So yeah, we'll start taking stuff apart. All right, so I've got everything pretty much electrically disconnected from our junction box here. The only thing that's left is we've got to disconnect where our bus bars connect. And the only way to see those fasteners is with a mirror. So you can see the ones on the top there, those are Allen heads. And then the one down here, those are going to be 10mm headed bolts. So we'll go ahead and get the tools for those, zip those things out, and then we should be able to take out the fasteners on the corners of this thing and get the actual box out of the way. I don't remember, I think that we can leave the 12 volt battery in here. It's not really in our way. And yeah, we'll be able to get this thing out. Then we can start removing the rest of the components here. Alrighty, I got our bus bar connections off. I've also removed the fasteners on all four corners of this thing. So we should be able to get this box disconnected now, unless I'm hung up on something else. Feels like it's trying to move. Oh yeah, there we go. It's just a little hung up on the gaskets, I think, where the bus bars pass through. Let's see. Let's try and get this harness out of our way. We're kind of bumping up against a low voltage wiring harness here, which makes it a little tight, but just a little bit of a push, and I should be able to make it out of here. There we go. I think that I'm basically clear at this point. Or am I still stuck on something? Feels like I'm stuck on something. I believe that I must have missed a ground. Okay. That would kind of make sense. Oh no, that's the high voltage cable that goes to the AC compressor. Okay. I missed that because it's on the bottom. So let me get this kind of sort of in position. And I think we'll have to lift the car up to do that because it's going to be easier to access it from underneath. Alright, we can go ahead and get our AC compressor unplugged here. So I've got a pick. Try and get this connector undone. I think that's it. There we go. Yep. And then just have to take off all of the harness clips on this thing. There we go. So we've got that loose. Now we can put the car back down and actually pull that junction box out now. All right, now the junction box can come out. We just got to fish that harness through. And boom, now we can set this off to the side. I think technically what I could do is I might actually be able to remove this whole thing without taking the traction inverter and stuff off. But is that worth it? I don't know that it really is, because we have to take it apart anyways. So I think we'll go ahead and take the traction inverter off and everything first. I think officially the procedure calls for taking all this stuff off first, which I think we're just going to go ahead and follow that, because otherwise we'll just be fighting with everything else, pulling the whole thing out just to have to take it apart at the end anyways. So yeah, let's go ahead and pull this thing off. The top piece here, the onboard charger, should come off pretty easy, because all that it should have attached to it at this point is perhaps a couple of electrical connectors. So we've got one right here, which is basically just like a data connector. So that one's unplugged. We've got a coolant hose, and the way that the cooling system on this works is on the bottom of this, it actually has a gasket. So the coolant, I don't remember if it flows in this side first or through the traction inverter side first. Doesn't really matter. It flows in one way, then it flows through into the other component, and then it exits out from the other one. I think that the onboard charger is where it flows in at. So you'd have flow in, then it goes down to the traction inverter through a gasketed surface, and then it goes out through that component via another hose. We've got some hoses on the back side and everything, so there's some additional brackets and whatnot that we'll have to undo. So let me get the right tool for that. Okay, so that's no longer attached. What else do we have here? We've got our electrical connector. Do I have any grounds that need to be undone? It does not look like it. So I think all that's left is just that coolant hose. And then we can just unbolt it. I might try to see if either I can try to siphon the coolant out of that or do something else to try and minimize the mess. I guess I could try and take the hose off of this pump, but I don't know how useful that's going to be. Maybe we'll try and drain the coolant out of the motor first. And maybe we can get that coolant level to go down and hopefully not make such a big mess. All right, I managed to get that coolant level down just a bit. We'll go ahead and get this hose off. All right, there we go. Got that hose off. Now we've got a couple other things we need to disconnect here. We've got a ground. Well, first let's disconnect our positive here. So that right there is our positive terminal off of the DC to DC converter. And we've got our ground. And then we've got just a little bracket here as well. Sweet. Got our data connector back here. And I think the only thing left is to disconnect the 3 phases. And then we can pull this thing off. All right, we're back. Got a customer coming to drop off a car here in a little while. So we want to disconnect our 3 phases there. So let me get a 10. And usually on these types of connections, I don't usually use power tools. So we'll stick with this. I need an extension though. Okay, there's 1, there's 2, and that's 3. I can't actually grab those though without a magnet, so let me get a magnet real quick. Boom. Okay, we've got all those. And now, we're almost ready to pull this thing off. There are a couple of other things that I've realized that we need to disconnect. Just some brackets, like this bracket right here holds on a pump. And then we've got a bracket back here that holds on some other coolant line related stuff. So we'll zip all those off. Is there anything else here that is gonna cause me a problem? I don't think so. I think we've got everything disconnected, so we can go ahead and pull this off. Those look like they're going to be probably 14s. Yeah, it's not a 13, so it must be a 14. And I think it's just those 5 bolts for that thing. Should be loose. Oh, look at that. I missed another bracket on the bottom side of this thing. Those look to be 10s, so let me zip those off too. It's right here on the front side. Might be out of frame on the camera, but dang it, I can't actually fit this thing in there. Not on this one bolt anyways. Okay, that one's coming off by hand, I guess. Okay, back at it again. I got you guys a little bit better view here. This is our bracket that we were stuck on. There's sort of a coolant valve here that can change where the coolant is flowing. I think it's a 3-way. Pretty sure it's a 3-way valve on these. But anyway, yeah, it just has a little bracket that attaches it to this thing, so we just gotta pull that off. My powered ratchet doesn't fit in here, and even that one doesn't fit super awesome, but just enough to get it undone. There we go. Now we're loosened off on that. Now our traction inverter can come off. So we'll just lift that straight up and pull it out. Okay, so I've gone ahead and taken loose everything here from the top side that I can really access. Any brackets that attach pumps, coolant hoses, wiring harnesses, all that stuff. I've removed all the fasteners, at least everything. I think I got it all. So what I'm going to do now is I'm going to go ahead and get the car up in the air. We're going to get the wheels off. We'll have to take the suspension apart, remove the CV axles. There's a few other brackets and stuff that are really only accessible from the bottom side we'll have to take off. But then we should be able to drop the whole motor and gearbox assembly out of the car, and then we can tear into it, see what kind of carnage we have in the gearbox, and see how noisy our motor bearings are. Okay, so we've got the car up in the air here. As I mentioned, I've got a couple more brackets and stuff that I'll have to undo from the bottom side here. I need to take apart the suspension, so basically what I'm going to do is I'm going to pop the ball joints loose on the lower control arm and the tie rod end, and then we're also going to unbolt the AC compressor here. I'm not going to completely remove the AC compressor because we don't want to have to deal with evacuating all the refrigerant, so it's basically just going to get unbolted, and I'm just going to hang it kind of off the frame rail up here. And then once we get all that done and pull the axles out and all, then we should be ready to go ahead and pull the whole motor assembly out. So pretty straightforward process. I'm going to get to it here, and I'll come back to you guys when we're ready to start dropping this thing. Alrighty, I've got everything disconnected, all of our brackets. Our AC compressor's unbolted, and I've got it just strapped on, hanging there, hopefully out of our way. And we're finally ready to start dropping this thing. So what I'm going to do first is I'm going to get it supported on the jack here, and then I'm going to start taking the bolts off the mounts. The rearmost mount has 3 bolts in it that we're going to take out. And then on the 2 front ones, there's one on each end, they kind of have big plates that attach them. This side, I'm going to remove it from the plate. Since there's a bunch of other stuff attached to that, I'm going to try and leave the plate portion in the car, I think. And then on this side, I'm going to probably leave the plate attached, and I'm going to unbolt it from the motor mount on the top side. So I'll have to grab the ladder when we get to that point. But let's go ahead and get the jack up here into position. I'm going to need some blocking probably to properly support this thing. I kind of need a better jack setup. It's one of those things that I keep meaning to do, but I'm working with what I've got here. So our heaviest portion is going to be the motor off to this side. So I'm going to want to try and offset the jack this way a bit to try and get the most support that I can on this thing. I might even push that back just a smidge. Can we get this to lay flat on those 2 ears? Yeah, that's actually on there pretty good. So I just need a block under here to support that, which it's going to be a pretty thin one. So let me see what I can find. I think this right here ought to do it. Oh yeah, that's perfect. So if I take just a bit of pressure off and then jack it back up, we're on there. Awesome. So now what I'll do, just for extra security, I'm going to go ahead and strap the motor to the jack, because we don't want this coming apart on us. The tricky part's going to be fishing the strap through all of our brackets and wiring up here on top. All right, we're going to attach that right there, I think. I might even try and go on the other side of this. There we go. That'll do it. I'll try and get this strap attached. I think we're good there. So now I can start actually unbolting everything on here. Looks like we're going to be probably 17 millimeter for everything. Oh, I think everything is all 17s. Okay, well, I'll get started on that, and we'll be dropping this thing out shortly. All right, all that's left now is to get these fasteners off of this mount, and then we should be good to go. So I'm going to pull. I'm going to just leave that one on there finger tight. For exactly that reason. So that thing did drop down a bit. I'm going to go back down. Oh, never mind. I was going to say, I want to make sure that that doesn't have a bunch of pressure in it, because we don't want this thing just falling out on us. Oh, look at that, we should be free. So I'm going to head back down to the bottom, and we'll go ahead and lower this thing down. All right, we're going to go ahead and gently start to lower this. I want to make sure we're not going to catch on anything. There's a lot of different components in here that we could get caught on, so we're just going to go nice and slow to start. I think we're doing all right so far. This hose probably I should pull off just so it's not getting in our way. It actually wasn't attached to anything on the top side, so I left it on the motor, but it's kind of snaking through a bunch of stuff and getting in our way, so we'll go nice and slow. Okay, we're starting to get to a point where stuff could start getting hung up here. Just make sure we're not caught. And the rear here, our gearbox is going to start hitting the subframe, so we have to start pulling the motor back this way, which also, you know, continues to add to the drama of catching on stuff. We'll try and... yeah, we're starting to catch the subframe there. Maybe I can rotate a bit. Or try to pull back. You know what? I'm going to go ahead and pull this mid-aero shield because that'll give us more clearance for the back of the gearbox to fit through here. All right, that gives us some more room to play with. Oh yeah, we can almost drop straight down. Oh, and I just noticed a key piece of the puzzle. We missed one fastener on the bracket back here for the high voltage battery cable. So good thing I caught that. Wouldn't want to miss that one. Okay, I'm gonna have to undo my strap here, which I kind of don't like doing when they're not attached to anything else, but I don't know that I have a lot of choice in the situation here. I'm gonna try and go up a bit, I guess. I got the strap caught on one of the brackets for this coolant pipe. Maybe I can push it. Oh yeah, there we go. Okay, now we're free. I was able to just push it out from underneath. Okay, I think we are completely free at this point. Finally. Back down we go, nice and slow. Pull back a bit. And keep going down. Oh. Now we've got a wiring harness getting caught somehow. It's not bolted in, so what's it caught on? There we go. Guess that was just caught on a fastener there. But now we're clear. All right, all the way down. And look at that, we've got the whole drive unit out of the car. So yeah, there we go. That's the whole motor assembly out of the car. So our next step was we can go ahead and push this out. We'll separate the motor from the gearbox. We'll get prepped to put our new gearbox on the motor. And we'll probably tear this gearbox apart because I'm curious to see what actually failed in there. It's pretty amazing that it actually cracked the case right there. This is actually where the primary drive gear bearing would live. So it's pretty interesting. Definitely pretty catastrophic failure must have happened to crack that open like that. But yeah, I guess we'll take it apart and find out what the actual failure was, whether it was the primary drive gear that broke apart, maybe the bearings came apart and caused something else to happen, maybe some of the gear teeth stripped out. In any case, yeah, I guess we'll find out shortly. Alrighty, so we've got the motor out off the stand. I'm going to take a couple bolts out on the bottom here, and then we'll drop this thing on the table and I'll actually split the gearbox. I can't really fit this thing onto any of my motor stands super easily with the way it's set up, so we'll just work on it on the table here. We'll go ahead and drain the oil out, but as you can see, I already made a little bit of a mess of it, so I don't know how much is left in here, but I'm real curious to see how it looks when we drain it out. So, I've already loosened the drain plug off here, and let's see what we get. Oh yeah, look at all the shinies in there. Look at all that metallic schmoo that we've got going on in there. Now that's pretty common on the Kona and the Nero for these gearboxes. They tend to get a lot of metallic buildup in the oil, and part of the reason for that is that they don't have magnetic pickups on the drain or fill plugs. There is a magnet in the bottom of the gearbox here, but it's not fixed in position. It just kind of rattles around in there. It's fixed in the idea that it has a pocket, but it's not solidly attached to anything. So it just rattles around, and I don't think that it can really effectively pick stuff up as easily, or at least the metal particulate doesn't stick to it as much, maybe, because of the fact that it is rattling around, or maybe it's other design flaws with these gearboxes, but clearly, yeah, that's a lot of oil in there. That's a lot of metal in there, which obviously is to be expected given the fact that we've had such a catastrophic failure here. So I'll be really curious to do an autopsy on this thing and see what it was that really failed. But what I'm going to do for now is we're just going to go ahead and get the gearbox and the motor split from each other. So I think in order to do that, I've got a few different fasteners. I want to take out the two on the bottom since we won't be able to get to those once we get this thing dropped. So let me grab some tools and do that. All right, let's go ahead and try and get this thing all taken apart. So I'm going to get all these broken loose. This one already is loose. Yep, that one's loose. Just go around the perimeter here. Of course, I already took the two bottom ones out, as you guys saw. All right, now I'll get the powered ratchet here, and we'll zip those out the rest of the way. There we go. Okay. All the fasteners out of the way. There we go. Oh, dang. It did ruin the motor splines pretty good there. That is a bummer. So we do indeed have some pretty significant spline wear issues here. If I can get the camera to focus so you can see, just how big of a divot there is there. It would probably still mate with a gearbox, but yeah, that thing's pretty wallowed out. That does not look happy at all. And then the motor side, yeah, that does not look good. And you can see it's been leaking out of there. Actually, you can see, I don't know how well it shows up on camera, but you can see that this gear is off kilter. It's not aligned properly. So I'm going to say that this was probably operating like this for a while, and look at all this metallic buildup. Look at all that stuff right there. That is crazy. Wow. And of course I was talking about not making a mess of my table. So much for that plan. Okay, well, I might have to follow up with the customer and let them know that it does look like we are going to end up needing a motor, which is pretty unfortunate. I was hoping that the splines on this thing were still going to be okay, but clearly they are not. So, yeah, I guess we can go ahead and still split the gearbox open, see what kind of carnage we've got going on there, and I'll have to see how much I can find a replacement motor for, because yeah, there's nothing that we can do about those splines. That's pretty much it for that one. I did also notice, so there is supposed to be like a little plug that's meant to be threaded into the end of this, and I don't know where it went. Let me grab a light and see if we can see anything in there. All right, I got a light, and that plug, of course I can't really shine it in there very well without blocking the camera, but you can see it in there. That plug did come off. But yeah, look at just how bad the splines are in the gear here. That is pretty rough. All right, let's go ahead and get this thing torn down. All right, let's start blowing this thing apart. So we'll pull our parking pawl servo off. By the way, this is the exact same parking pawl servo motor used on the Leaf, the Toyota RAV4 EV, and the Mercedes B-Class Electric. More or less. I think the bracket's different, but the actual servo is the same. And I'm sure it's probably used on other vehicles as well. My God, that thing is stuck in there. There we go. Okay, I think I'm gonna put this thing on this side because that is gonna lend itself best to us taking this thing apart. What just fell out? Oh, that was the little plug out of the rotor. Look at that. It's been rattling around in there for so long that all the threads are gone. Almost. You can still see them just a tiny bit right there. Either that or it's got stuff caked into it. But the threads are still pretty smoothed over. Okay. Everything else on here I think are going to be 14s. So let's get this socket and this wrench. Wait a minute, no, those are 12s. I guess we can use the other one. But we do need to take out this guy right here. And then we can take everything else out. That should be all of the fasteners out. I think we can go ahead and split this thing. I don't think that's going to get in our way. Look at that, we've got a convenient little spot here to pry, maybe. May or may not have to break out some other tools to try and get this thing apart. All right, if this one doesn't do it, we'll revert to the old razor blade trick. But this might actually get the right amount of leverage. Nope, that one's just slipping as well. Okay, razor blade it is. This is basically just glued together with silicone gasket maker. So once we break that bond, we might actually be able to pry it apart. Maybe. Maybe not. I might have to wedge it apart a little more. Oh, there is one. Silly me. We've got one right there. I forgot about that. It's been a while since I've had one of these apart, which I've only ever had one other one apart out of a Nero. Alrighty. Now let's see if it'll split. Oh, look at that. It actually comes apart when you take all the bolts out. Dang. Look at the carnage there. Look at all the bits of metal here. Oh, this is the bearing race. And there's some of the balls. Yeah, this thing completely disintegrated. Wow. That is something else. Let me get this kind of arranged here in a way that I can show you guys everything that's going on here. All right, so I've got it all laid out here for you guys. So this half of the case is just flipped right over the top. So it's in the same position, just flipped over, mirrored. So doing some failure analysis here, it's pretty clear that this bearing right here failed. So that bearing is what rides on this end of the primary drive gear. Now this is called the primary drive gear because this is the one that's directly attached to the end of the motor right there. And then it transmits power to the counter gear, which rotates in the opposite direction. And then it transmits that power to the differential ring gear, which then rotates again in the opposite direction, which is the same direction as the input. But yeah, so this bearing on the primary drive gear failed. I mean, it literally came apart. We can see pieces of the bearing race here where, I mean, it basically just exploded into pieces. We can see some of the balls back here, and some of them were up there in the other section of the case. And we've got all these other chunks of metal that are probably from a combination of the case itself, the gear, and of course the bearings. Now, the way that these gears are cut, these are, they're cut at an angle to each other. They're actually slightly curved, the way the angle is set up on them, but they're always pushing against each other, and they're always wanting to push out away from each, well, away isn't the right word, but because they're at an angle, they're always wanting to push into or out of alignment with each other. So the bearings are what keeps everything in position. Now, when this bearing failed, there was nothing left to prevent this gear from moving in that direction other than the case itself. And you can see it wore a huge hole into the end of the case. That's why we have that big crack there. I mean, the aluminum in that section is probably, you know, just hair thin, where it was just barely being held in there. So it's pushing into the case, and in addition, it's also lost support in, you know, this axis. So not only is it trying to push this way against the angle of the gears, but it's also trying to push away from this gear. So you get less tooth engagement, and it's pushing away, which leads to a reduced area of engagement on the gear teeth. Again, you can see it just wiped out that whole inner edge of the gear teeth, where there's almost nothing left contacting it anymore. I mean, there's a little bit of contact there, but not enough to transmit any power. If you put any kind of torque on this, this thing's just gonna push a little bit further out of the way, and you get no power transmitted. And then, of course, because this is pushed out, you can actually see that bearing down there should be fully seated flush into the case. Because that wasn't seated all the way in, this star wheel here is what engages on the parking pawl mechanism. So this was probably enough out of alignment with the parking pawl mechanism that it could no longer lock it into park. So that's a, you know, just a whole nother thing in itself, is this car could not be put into park. If you tried to put it into park without the parking brake on, it would just roll away. Now, obviously, it was totally undrivable in the first place when this actually failed, but this is a pretty substantial failure. Probably the worst gearbox level failure I've seen, short of gearboxes that I've come across that were run without oil. But yeah, I mean, this is pretty major. This is one of the reasons why it is so important to change the gearbox oil, particularly on certain vehicles like the Kona and the Nero that are prone to bearing and gear train wear issues. Now, some cars, it's not so much of a problem. Some cars, it's more of a problem. But no matter what, any moving parts are always going to wear, and you're always going to end up with metal particulate in the oil, no matter what. So no matter what gearbox you have in no matter what EV, there's always going to be some amount of wear, and that metallic particulate is getting deposited into the oil. Now, sometimes they have a filter to pick that stuff up and keep it from circulating in the oil, but it's still a good idea to service your stuff before it breaks. So yeah, unfortunately, because of the alignment issues on this gear being pushed out of the way, it put a lot of stress on the rotor end here, and it caused this really abnormal wear pattern on the splines. This probably could still transmit power through the gearbox, but there is very little material left on those splines, and it probably would not last very long. So unfortunately, it's looking like we're going to need to source a replacement motor for this thing as well. Because yeah, there's no fixing that. I mean, short of sourcing a replacement rotor, which I highly doubt that we can source a rotor for this thing. I can try and search to see if it's possible to get one, but I doubt it pretty highly. So more than likely, we're going to have to be searching for a replacement motor. A used motor is probably going to be the best bet. There's no reason not to use a used one. What'll most likely happen is if I do source a used one, we might put new bearings in it, but the rest of it's fine. Now the gearbox itself, I actually already had ordered a brand new gearbox straight from Hyundai. The cost for a brand new gearbox was only a few $100 more than a used one. So it just made more sense to get the new one, because a used one, there's a high likelihood you have noise issues, might have to rebuild it, and then it becomes more expensive than just buying the new one. Now, if this was a gearbox that only had noise issues and didn't have these gear train failure stuff, then it could be rebuilt. I've actually rebuilt these before. Just take it apart, replace all the bearings, put it all back together, and then it's whisper quiet. I did that on a Nero here maybe about a year ago, give or take, and it turned out perfect. No issues after the rebuild. So anyway, yeah, I'll have to find a home to put all this stuff on a pallet or something, get it out of the way, and I'll have to follow up with the customer, let them know that it looks like we are going to need a motor, which is unfortunate. I was hoping originally that that was not going to be the case, but it looks like it is going to be the case. So anyway, we'll come back to this when I have an update, probably after I have a motor come in, and we'll start putting this thing back together again. Alrighty folks, it's been a few days, it's the next week here. We've got to get some parts opened up. So the motor for the Kona here just showed up this morning. The gearbox, of course, we already had. This is a brand new gearbox, straight from Hyundai. It's not worth trying to go with a used one for one of these, because A, they're already so prone to noise issues, so with a used one you would want to rebuild it anyways before using it. And B, the cost of a brand new one was only a couple $100 more than a used one anyways. So much better to just go with the new one. And then for the motor itself, we are going with a used motor. We may end up needing to replace the rotor bearings in this. So I've already quoted the customer and all for that. We'll check it out, see if it actually does need the bearings replaced, and if it turns out it's pretty quiet, we'll let the customer know and decide if they want to forego that. Essentially, the gist here is that the new motors are ridiculously expensive for these things. I think a new motor is on the order of about $6,000 from Hyundai. Meanwhile, we can pick up a used motor for what? I think this was about $1,500 plus or minus. So we'll go ahead and get this opened up, and we'll check it out, make sure there's no issues with it. It looked fine when I originally saw it listed online. So we'll get this all opened up, and they've got it pretty well packaged in here, it looks like. All right, I'll get all this cut apart, and I'll bring you guys back when we have this thing all opened up. All right, so we've got our motor pulled out of the box here. It looks pretty clean. I did notice, I mean, obviously they've got the coolant inlet and outlet capped off, but they also have this little rubber cap on the connector. So that makes me wonder if this did come from like a Hyundai dealer or something. Maybe it was a core. It doesn't look like it was a new motor. So yeah, let's spin it up and see if the bearings make any noise. So we'll just stick our drill in this little plug in the end. Okay, so it does indeed have pretty noisy bearings, which was kind of to be expected, so that's kind of what I went into this expecting to do. So we'll go ahead and pull the motor apart. We'll replace the rotor bearings, and in doing so, we'll also be upgrading them. And then we can go ahead and start getting this thing put back together again. By the way, just a fun little experiment here. I've got a multimeter hooked up to 2 of the phases on the motor. This is a permanent magnet motor, so it is going to produce voltage if we spin it, even if there's no load on it or an inverter to do anything, because the rotor is magnetized, so it's always got a magnetic field present. So just by spinning it, we can induce a voltage. So if we go ahead and spin it up again here real quick, you see we can get it up to just about 60 volts at the RPM that this drill spins at, which is not that fast. All right, so I guess before going too crazy with tearing our motor and stuff apart, I did want to open this up and make sure our gearbox is correct. They use this giant block of like expanding foam in there, And then we've got the whole gearbox packed up in a bag here. Interestingly, it actually comes with the parking pawl servo and the motor mount attached, which I didn't really expect. I thought it was going to come totally bare bones, but it does have all that stuff on it, which is kind of cool. So less stuff that we'll have to transfer over. This isn't too terribly heavy, so I can just lift it out of here. And yeah, I'll go ahead and get this set on the table. All right, so as you can see, we've got our replacement motor and gearbox up here on the table. As you can see, I've actually got the motor strapped down to the table. That's because we are going to pull this end plate off and pull the rotor out. Now, this does have, as I mentioned before, permanent magnet motor, so the rotor itself is actually magnetized. It gives quite a bit of resistance to actually pulling the rotor out of this thing, so just strap it down so that the motor's actually kind of mounted to the table and we can pull the rotor out from the end plate here. So I'm going to go ahead and zip all these bolts out, and then we should be able to start separating the end plate here and actually pull this thing off. All right, new idea. We'll take my brass hammer and we'll kind of give this a good thunk on here and see if this separates. Oh, look at that. We did get some separation. Sweet. All right. It's just a matter of getting past that layer of adhesive. Oh, yeah. We're home free now. So now, the real trick is that because the rotor is magnetic, it's actually attracted to the steel laminations in the stator. So it's going to rub on the stator the whole time we're pulling it out. It sounds pretty awful, but it's really not hurting anything. But it does take a fair amount of force to get it pulled out of here. So I'm going to try and make sure the table's locked down so it doesn't move. And then we'll just give this a pull. And by the way, I don't know if you can see that in there, but there's a retainer plate on the rotor bearing here that is keeping the rotor attached to the bearing, essentially. Actually, this is basically the same motor as that Ionic motor that we rebuilt a few months back. So same basic principle. It's got that same retainer plate and everything. But we'll just go ahead and give this a tug. Maybe. Might need to get some bigger pry bars on here to get it moving for us. Let's see if I can get this in here. Just want to make sure not to damage the windings, prying against anything that we shouldn't be. All right, as you can see, we've got the rotor out. I've brought it over here just to a plastic table. Like I said, this thing is quite magnetic, so we don't want to be working on that on the steel table. Works a little bit better when you have something non-ferrous. Yeah, and just everything sticks to it. But that bearing right there is our problem area. Don't know if you can hear that, but that's not the way that should sound. So, and you can also see all this sort of red dust. That's actually basically just powdered rust material. And that's probably going to be from that bearing. Actually, if I tilt this up, you can see in here there's only part of the rubber seal ring on this bearing left. So it looks like it actually got hot enough to melt the rubber seal on this thing, and it probably cooked all the grease out of it, especially based on the sound. Now if we spin the other end, you can probably hear maybe just a little bit of a grumbling noise there, but that bearing's not nearly as loud as this one. And we also don't have all of our red dust on it. So anyway, we're going to go ahead and first I'll probably try and pull the end plate off here, so we'll have to undo the bolts there. Then we'll take these bearings off, replace them with our new ones, and then we should be able to get the motor put back together. All right, now we can get to pulling this thing off. It's kind of tricky to get this retainer plate off because the rotor's magnetic. Almost need like a titanium wrench or something to do these, because you're fighting against the rotor the whole time to get the wrench in there. And then we've got to break that loose. Once we get it started though, they come out pretty easy. So you only have to really get like half a turn on it with the wrench before you can run them out. by hand. The problem is that we can't get them all the way out because the bolts actually run into the rotor. So we have to get each one loosened, pull the plate off part way, and then loosen the bolts the rest of the way. And of course, when this goes back together, we definitely do not want to forget to leave the spacer in there when we put the new bearing on, because it does go behind the bearing. I've made that mistake before, and it is not a good time. Okay, so we've got that, and let's see, can I actually get that out of there just by pulling on it? Probably not. I might need my puller on here. Or we can try and give it some gentle taps with the brass hammer. Or a dead blow. Dead blow would work too. Actually, dead blow is probably maybe mildly better, but this will be fine. And look at that. We're off. So that's all just going to kind of stay stuck on there. Actually, we can just leave it right there and it'll stay stuck to the rotor. That way we don't have to worry too much about forgetting about it. And yeah, so this bearing definitely still has grease in it. See how it doesn't maintain any momentum when I spin it? That's because it's got grease in there, which adds a little bit of extra needed force to overcome that. But this one, we've got no grease in it at all, so it basically just free spins. So let me go ahead and get my puller. We are going to need to take this circlip off, but we'll go ahead and grab the puller and we'll get this thing pulled apart. All right, let's go ahead and get this bearing pulled off here. So our first step is that we've actually got to pull off our circlip here that retains the bearing on this end of the shaft. I honestly don't even know why they put one on here. It's kind of pointless. But we'll go ahead and pull that off real quick. We'll get our puller on here. Okay. There we go. One bearing off. So there's our old bearing right there. That one wasn't in too terrible shape, but we're going to go ahead and replace them both anyways. Now these original bearings are just normal steel ball bearings, nothing special about them. We're going to go ahead and replace these with the hybrid ceramic bearings. The ones that I use on these are actually the same size that would be used in the Tesla large drive unit, but the bearings that Hyundai and Kia used on these motors from the factory is a freakish non-standard size. So it's almost the same size as a standard 6007 bearing, which I'll show you guys here real quick. So this is our 6007 hybrid ceramic bearing. So dimensionally, it's the same outer diameter, same inner diameter. The only difference is that it's 1 millimeter narrower. So all that we have to do is compensate for that with some shims. So because this does have a circlip on the shaft here, I'm going to use a shim on the inner diameter, just so it shims it properly like so. And then on the case side, I will also have a shim in there as well, which I don't have right here in front of me, but it's basically just a shim that would go around the outer diameter of the bearing. Let's go ahead and get this bearing installed, and then we'll go ahead and swap out the bearing on the other end of the rotor as well. There we go. Bearing is fully installed on there. So we'll get our inner diameter shim. Just stick it into place right there. And then we can get our snap ring back on there. Make sure that's fully seated. Sweet. Now I can move on to the other side. So on the other side here, we have to take this resolver ring off, which I think I'm going to need a spacer to fit in there, and I probably want to try and clean off as much of this kind of rust powder as I can. It is still ferrous and somewhat magnetic, so it does want to stick to the rotor. So I'm going to go ahead and clean that off as well as I can here real quick. Alright, I had to reconfigure my puller for 2-jaw configuration, but we've got that going now, so we'll go ahead and get this cinched down into position. I think we've got a pretty decent grab on there. Let's go ahead and get this resolver wheel off. Boom. There's that. It's our little resolver wheel, and this is just a collar that presses it on there. So this actually fits on here loose. It's not on here tight at all. At least if I can get it positioned in the right spot. So yeah, that's just on there loose, and this collar just locks it into place. Let's go ahead and pull the bearing off now. And then we can go ahead and swap a new one on right here as well. All right, there's that bearing removed. Now we can go ahead and install our second ceramic bearing. Fully seated. This one, of course, doesn't have the snap ring or anything on there, so there's no extra spacer that needs to go here. All that we've got to do is get our resolver wheel back on here. So just like so. We'll get our little spacer ring lined up. I think we're just about fully seated on there. Give it a couple taps just to make sure. And there we go. We've got new bearings on both ends of our rotor here. Now all that's left to do is to go ahead and reattach the end plate. All right, so we've got our end plate fully bolted on there. All that's left to do is to go ahead and get the rotor reinstalled back into the stator here. Of course, I do have another spacer ring right here, which is going to go back there. The easiest way to get the rotor reinstalled on here, since it is magnetic, it actually almost kind of sucks itself in there. But what we're going to want to do is get this thing set up vertical, so I'm actually probably going to put it on the floor, and then I'll be able to just basically drop the rotor right in. So that's the idea. I'll go ahead and get that set up, and we'll get this thing put together. All right, we're ready to go ahead and get this thing sealed up. I cleaned up the gasket surfaces and applied some new sealant. We'll go ahead and get our shim in here, right where it needs to be. And then let's grab our rotor. And I'm basically just going to drop this thing in here and let it almost kind of suck itself into place. And look at that. That's actually fully seated. I didn't even have to draw it in with the bolts. So we'll go ahead and get all those tightened up, and then we should be ready to mate this and the gearbox together, and then we can start putting it all back in the car. All right, we've got our motor fully put together. We're just about ready to attach the gearbox to it. I am going to take the mounts and everything off the gearbox because that is going to make things way easier to get it into the car. We didn't actually need those mounts. I'm probably going to transfer them to the car just because we can. I mean, there's no rubber pieces or anything to those mounts. They're just solid aluminum blocks. So there's not really a reason to transfer them, but we've got new ones, so we might as well do it anyways. On the motor here, I just wanted to show you guys how much quieter it is with these new bearings. So we'll go ahead and spin this up. And you can hear it's almost silent. We've got just a tiny bit of noise. It's probably more than anything likely just from the cogging of the magnets in there. But yeah, so that's it for that. I'm going to go ahead and pull the mounts off the gearbox there, and then we'll go ahead and get it mounted onto the face of the motor here. All right, let's go ahead and grab our gearbox here. I'm going to pick this up, and then I am just going to mate it with the motor. So just got to get the shaft lined up, like so. Probably just give it a little bit of a wiggle. Okay, we're mostly lined up there. Probably just draw it in with the bolts a little bit. I've got these shorter ones that go up top right here. And let's see. The other two short ones go on the bottom, so we can't really get to those unless we flip this thing around, but we can get the long ones in on the sides. So go ahead and basically just get everything lined up. I'm just gonna work this in, kind of tighten the bolts by hand, and then we'll get this thing to slip together. All right, we've got one more thing that we need to transfer to the motor, and that is this end plate from the old one. So we'll go ahead and get this bolted on here. Get all the bolts started, and then I'll run them in with our impact driver. Alrighty, I think we've got that down. Now I want to check and see if this gearbox actually has any oil in it. I suspect that they may have shipped it with oil in it, just because of how sealed up it is, I guess. And if I pull these plugs out and look inside the gearbox, you can see that there is oil in there. So I'm guessing it's full of oil. I'm going to pull the fill plug out and check. I also want to know whether or not they have magnetic drain and fill plugs on this thing. If not, I'll probably want to put a magnetic drain plug on it, which means I'll have to drain the oil out. But it should be fresh oil, so we can just dump it right back in. But yeah, let me pull the fill plug out. We'll see what the oil level is and whether or not those are magnetic plugs. I think that I've read that the newer revision of these gearboxes does have magnetic plugs, but I could be wrong. So let me grab a wrench and we'll check that out real quick. Yep, that is full of oil. I'm gonna try and see if I can tip this up. Try and keep from losing all of our oil out of this thing. And that is not a magnetic plug, so I guess we're going to drain the oil out. We'll put a magnetic drain plug on it. Fill plug doesn't really matter so much, since the oil level's only up just to the very bottom of that, essentially, so it's not really going to have a chance to pick up anything. But the drain plug, we do want to put a magnetic plug on there, because these don't have a super good magnetic pickup in the gearbox, and it just leads to problems. So let's go ahead and swap that out. All right, let's go ahead and take out our drain plug here. Maybe, if I can get it loose. That thing is on there tight. There we go. Okay, I've got a fresh, clean container here to catch our oil so that we can just put it right back in. Make sure that comes off with the drain plug here. Okay. And then this right here is going to be our magnetic drain plug. Fun fact, this is just a Toyota / Lexus rear differential plug, and it happens to be a perfect match for this thing. If you just search for one for like an LX470, Lexus LX470, same rear drain plug. I'll let that continue running out here for a moment, just so we don't make too big of a mess. That's probably good enough. And we'll go ahead and get this thing threaded in. Okay, that is on there. And now we can go ahead and refill the gearbox. I'm probably just going to go ahead and refill it just through the differential hole there, and then we can get this thing installed. All right, so I was actually going to go ahead and swap out this mount that goes on the gearbox off camera, but I made an interesting discovery. So this is the old mount that I just pulled out of the car, and this is the new mount that came with the new gearbox. And as you can see, they've made a revision. They've actually split it into two pieces, and I assume that this is for serviceability reasons, because it's a little bit more difficult to pull out all these fasteners on the side. There's also, well, I guess we are looking at the side that mounts the motor, but on the gearbox. But on the gearbox, there's actually, well, I guess there aren't any mounting dowels. Oh, there is one mounting dowel on the gearbox. So there's a mounting dowel for, no, that's for the AC compressor. So yeah, none of these actually have any mounting dowels, but it is still a little tricky to get that lined up. So presumably they did this so that you could drop it out more easily by just undoing these three bolts in the top. We've already got this all apart, so I'm just going to put it in the way that it is and just put it together the same way I took it apart. But just an interesting observation that I made on that. So yeah, I'm gonna get this mounted back in the car, and then we can start actually putting the motor assembly in, which I've got on the jack right here. Alrighty folks, the next step here of course is to go ahead and get the motor in. So I've got it up here on the jack. I'm just gonna go ahead and jack it up in here, and I'll come back to you guys when we're getting it bolted in. Alrighty, we've got 2 out of 3 mounts on. We've got the one at the rear of the gearbox here, and we've got the one over there on the other side. Now I've just got to get the one on this side, which we have to do from up here. So I've climbed up on the ladder, and we've got this mount right here that attaches, so we're gonna have to scoot things around a little bit. I might have to go back down and give the motor a little scoot towards the back. Actually, I think what I really need to do is I just need to jack it up a little bit so that it comes more into line on this side. So anyway, I'll play around with that, and then we'll get this mount bolted on. All right, so we are now fully bolted in. We've got our mount up there, our mount over on that side, and of course the mount on the rear. So all that's left to do is to start buttoning up all of the rest of the stuff. So we've got tons of brackets and stuff in here for things like coolant pumps, this 3-way valve, all of the brackets for the wiring harnesses, our AC lines, all that stuff. So I'm not going to go too into detail with any of that, just like I didn't when we got it all apart. But yeah, it's basically just a matter of lining everything up where it needs to go and bolting it all back together. Once I'm finished with all the stuff down here on the bottom side, I'll probably bring you guys up to the top, and then we'll be ready to start reinstalling the traction inverter and the onboard charger and all that stuff. Alrighty, so I think we've pretty much done everything from the bottom side that we can for now, besides the suspension and stuff. We'll save that for last. But I've got all the brackets attached. I've got all the coolant lines connected. So now we've got to start with the rest of the underhood stuff here. So first things first, we're going to get the traction inverter into position. So let me go ahead and grab that here. I'm just going to set this down right where it's supposed to go. There we go. So that is in position. We're going to go ahead and get this coolant hose hooked up. I think we're good there. Then we want to get our 3 phases connected. So we've got that connected. We've got a data connector back here we've got to plug in. All right, sweet. So electrically, our inverter is now fully connected. We've got a couple more brackets of things that attach to the inverter itself. So I'm going to go ahead and get that stuff done here real quick. And then we'll get the rest of the hardware in here. All right, I've got everything buttoned up on the traction inverter here. So what's next is going to be the onboard charger assembly. So let's go ahead and get this thing on. And once again, it just drops into place. Just want to make sure we don't pinch that gasket on the bottom where it meets up with the traction inverter. Okay, I can feel that that thing's fully seated. So now we've got more connectors. So we've got our data connector that goes here. That's locked in. We've got our connector for onboard charger here. Oh no, sorry, that is the that goes into the junction box. Our connector for the onboard charger is back here, so we're actually going to forego that for the moment. We do have a little bracket here though that needs to be attached, and this coolant hard line that's on the back side also needs to get bolted on. So I'll button up the details here, and then we'll get the junction box on. All right, and the last major piece of the puzzle here is our DC junction box. So this we want to feed down here. That's our connector for the AC compressor, which kind of goes through all the wiring harnesses down that way. Okay, and now I can try to get this lowered into place. And of course, I just keep hanging up on stuff in here. There we go. Okay, that is in position. So we should be able to push this thing in all the way. Yep, just like so. Get a couple fasteners started just so it doesn't fall off of there. Okay. Some of these coolant hoses and stuff that I took different pieces of harnesses out of brackets and things. We can all get these all reattached. Some of these brackets stayed attached to the junction box here. Like that. This plugs in. We've got our high voltage connector straight from the battery that plugs in. So get that lined up. This one actually has like sort of multiple locking stages on the lever here. There's one, and the other one is just spring-loaded. Then we've got this connector. This would actually go probably to our PTC heater in the cabin, I believe. And the locking tab on that one we'll have to mess with here in a bit. And then we've got this cable. So this is our DC pins on the CCS charge port. Okay, that's locked in. And then we've got our AC charge port pins on this connector right here. And then we've just got some more brackets and stuff to get buttoned up. Oh, and of course we've got to get our DC connections down here plugged in. Or not plugged in, they're bus bars, so they just have some fasteners that go in them, and then these covers go over the top. So I'll finish buttoning everything up here, and then the last step will be to get the suspension together, and then we should be able to get the car started up, purge the coolant, and take it for a drive. All right, we're on to pretty much the last stage of reassembly here. Everything's put together under the hood. All that we've got to do now is get the axles installed and bolt up the suspension. So I'm going to go ahead and do that, and I'll catch you guys when we're ready to get this thing started. All right, minus the wheels and the underbody panels, we've got everything put together. I even pre-filled the coolant reservoir. Let's go ahead and get the high voltage disconnect reinstalled here. I don't know if I can really do this one-handed, so I'll probably get this done, and then I'll bring you guys back when we get ready to connect the 12-volt battery. All right, the high voltage disconnect is installed, so let's go ahead and get our 12-volt battery reconnected here. Plug this current sensor back in first. Okay. I didn't hear anything, but that might not necessarily be anything bad, although that 12-volt battery wasn't holding a very good charge before. Let's see. I do get lights, and I saw that it had the hood open icon up there a minute ago. Let's try and hit start. Not detecting the key. Well, I have a key right here, so there we go. Let's see. We'll try that again. I think the 12-volt battery on this thing might have gone dead after sitting. It wasn't doing so hot before, so let's get a jumper on it. All right, we got the jump pack on. I'm actually getting bings and bongs now, so that's a good sign. Now let's try and hit start. Okay. I heard the parking pawl engage. We are in ready. It says refill inverter coolant, which definitely needs to be done. Probably get the scan tool out and run a coolant air purge cycle. If we can do that with this. I don't remember if we can do that on the Hyundai stuff or not off the top of my head. And apparently the HUD is freaking out there. Oh, now it's working. Oh, can you guys actually see that? Oh, you can. All right, well, let me grab the scan tool. We'll run the coolant purge routine if we can, and then we'll get all the rest of the details buttoned up here. Actually, before anything else, we should see if we can actually drive. So we're in drive. Of course, we don't have any load on the wheels, but oh, it's gonna freak out with the door open. All right, door closed, in drive. And look at that. We do get movement. So we'll go back to park. Now I'll grab the scan tool and try and run the air purge routine. All right, we got the old tail out here and connected. Let's see if we can run a coolant air purge routine. Let's see, electric water pump. Look at that. That's probably what we're looking for. Water pump control. After adding one here. Oh yeah, remove excessive air for adding water. Okay. Test failure. Please check testing condition. Okay. Maybe it doesn't work. Ignition on, no DTC. Okay. Okay, it does not like that. Maybe we have a DTC set that it doesn't like. Well, let's go back then. And we'll go auto scan. Drive current high, battery voltage low, unstable. Okay, we'll just do a quick erase on that. Alrighty, let's hit escape on that. And we'll go back to hot functions again, and we'll try it again. And I guess we'll see if it actually works or not. Test failure. Okay, so apparently that does not work. Perhaps we can try a different thing here. Which module would that be in? It's probably not under motor control, but it could be. Oh, look at that, it is. We'll try it this way. Nope, still doesn't work. Okay, well, we'll just have to keep trying to fill the coolant. Can we actually see if it's gone down any on the level? Oh yeah, it sucked it all in, so we'll add some more coolant. Hopefully we can get all the air purged out without a problem. Alrighty, I've got everything all buttoned up here. Wheels are on, torque down. I think we're good to go. And we can take this thing on a test drive. Bingo. I did kind of do a couple on-off key cycles, and the inverter coolant warning actually went away with a couple key cycles, so maybe that's all that it needed. We'll see if it comes back on our test drive. Actually, I do need to grab the scan tool because we do need to run our resolver offset learn, since we do have a different motor now. And yeah, so we need to do that on our test drive. Make sure this thing's calibrated properly. Let's go. Alrighty, we're getting ready to pull out onto the street here. We want to go to special functions under our motor control system. Let's see, we'll get the kickstand up on this thing. Oops, I hit the lock button. We want to do initialization of automatic resolver offset calibration. So we're going to hit proceed, ignition off. Okay, so we'll go park, ignition off, and turn ignition on. Press OK. Okay, function has been initialized. You can see we've got a check EV message, which should disappear as soon as the resolver offset learns itself. So let's go ahead and just take a little drive here. For now, we'll just kind of go around the block, and we'll see if that resolver offset learns. So our check EV message should go away when it's finished. Sounds nice and quiet. Got no problems. Oh, we did get a low tire pressure light on, so we'll have to check that out. Yeah, it looks like our front right is pretty low. I think it was low when it came in, so it must have a leak. I don't do tires though, so it'll have to go someplace else for that. I don't remember if we have a minimum speed target that we need to hit. We might. So we'll kind of get out onto the main road here, and then we'll see if that clears itself. All right, we're getting out onto a street here where we can get it up to speed a little bit, because we might need to hit a minimum speed target for that resolver offset. Of course, if we don't get stuck in too much traffic. But yeah, we'll try and get that thing tuned out of there. Okay, we're going up to speed, and I just had a loss of power, and then our thing cleared there. So And that's exactly what it describes. It says that it coasts for 2 seconds, so you lose power for 2 seconds, and then it does its learning procedure, and then that's it. So it looks like we're good to go on this thing. I'll go ahead and get it back to the shop. I'll air up the tires, and then this car should be ready for pickup. Alrighty folks, well, another day, another EV back on the road. I think that's gonna do it for this one. Obviously this was a pretty extreme failure mode, but like I mentioned in the beginning, gearbox and motor bearing noise issues are a pretty common problem for the Kona, the Niro, and their other sister cars, the newer generation Kia Soul EV, which we didn't get here in the US, and the original Hyundai Ioniq, the Ioniq sedan, pre-EGMP stuff. But yeah, I've never seen one driven to complete failure like this, but this is a good example of why, if you do have issues like powertrain noise related problems, whether it be for one of these cars or for really any car for that matter, it's really something that you should get taken care of sooner rather than later. If this would have been caught earlier on, the gearbox and the motor probably would have been rebuildable, and it would have been, a fraction of the cost for this repair. I would say probably about a third to a half maybe of the cost. Bit more labor time, but way fewer expensive parts. So yeah, I guess that's enough of me ranting about that. So yeah, if you got any questions, feel free to leave them down in the comments. And as always, thanks for watching.